Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 256, number of unique good subsequences. So this one was very hard. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. I end up spending about an hour, more than an hour on this one, and I kind of just, to be honest, guessed at the end. I think I just just to kind of give you a little bit of spoiler alert, I kind of think I've done something similar to a unsimilar problem, and I think I guessed on the answer and it happened to be right near the end, which is kind of a ridiculous way of saying it, to be honest. But I do have an explanation for you, so show some support by hitting the like button, hit the subscribe button, join me on Discord, especially if you like contest problems. Come and hang out, we'll discuss problems all day. Hey, so I'm cutting into my own explanation real quick to give a better explanation, because after some code reviews, I actually like the solution more. You can still kind of keep watching to see how I did, how I explained the way that I solved it during the contest, and it still works. It's still a thing that comes into play for counting distinct subsequences. But I find that for this one, it actually, this code is way better, and I really should have gotten this during the contest. And it's odd that I think during the contest I did dismiss it because I didn't think it would take care of the uniqueness of it. But after I kind of actually went through the code, I was like, oh, of course this does. So yeah, so this is the code. So the observation that I made in the other video, or the other part of the video, which I will make again here, is that the key thing to notice is that you should go from right to left. And if you go from right to left, that lets you kind of get rid of the zeros in a way that I'll show you in a second. And basically here, zeros is the number of unique good subsequences for this suffix, for this current suffix. And same thing for ones, starting with 0. And same thing here for ones, except for so same thing that I'm literally copying and pasting. And then here, basically the idea is that for, you see this easy formula and you see how does it work, right? But basically the idea is that, okay, you start with an empty string. So this is basically this contribution, right? So the empty string, there's always going to be one empty string. And then now you go, okay, there's a 1. Well, what happens, right? Well, 1, then you take, well, there are only 3 possibilities, right? So let's say this is 0 for now. There are only 3 possibilities now that we're processing a 1. When we process a 1, we can add this 1 to an empty string. So that's 1 plus, let's just say, next one. So this is 1 because we can add 1 to the empty string, plus we can add 1 to the number of zeros, because basically the idea is that you're adding 1 on every suffix of 0. Of every string that starts with 0, you add 1 to it, right? In this case there's none, so we just add 0. And here you add another 1, because another way to say it in English is that we add 1, the prefix of 1 for every subsequence that begins with a 1 at this point. That's 0 again, so that's 0. So okay, so after 1 iterations, this is 1, right? And this represents number 1, literally. And then now the next number is 1 again. So then what does this mean? This means that, okay, let's say we add 1 to the empty string. So we get 1, the string 1, so that's 1. And then now we also add 1 to all the subsequence that begins with 0, which there's none, so that's, another 0. Plus add a 1 to all the ones, all the subsequences that begins with 1. In this case it's just 1, so now this is 1 1. So of course this is, you go to 2, which is 1 and 1 1, right? Okay. So then now you update it. And then same thing for the next one. So let's pretend let's skip ahead a little bit. And then now we go to 0. And in this case, what do we have here, right? We can add a 0 to the empty string again. So that's just this string. We can add a 0 to all the 0 strings. There's none. So let's just, this is 0. And then now we can add a 0 to all these strings, right? So that's basically the idea. And this is going backwards. And we'll explain why going backwards is the key in a second. Yeah, and then next step we add a 1. So then again, this adds this 1. This 1 is for the empty string. We add a 1 to all these numbers, so that's just this number. Yeah, and then we add a 1 to all these numbers, right? Note that, of course, this is by definition that every subsequence here begins with 1, right? So now we have 7 of these. Yeah. And then now we do the next 0, and then I'm not gonna look at it too much. This is, oh, did I miss one? I missed the ones. I missed adding it to this one, so I messed up. So this is 8. Yeah. Okay. Right. And this should be 4. Okay. Yeah. Yeah. And that's basically the idea, and you can kind of work it out your way at home to see. That's basically the idea about this magical formula. And then the answer is, okay, they ask you, there's no, basically, these are all sequences that, so zeros at the end of this loop contains the number of total subsequence that begins with 0. But of course, as part of the problem said, you don't want any leading 0. And if you have at least 1 in the beginning, that's going to be a leading, that's going to be a good one. So that's the answer is just 1s. However, you have to keep track of at least 1 0 because it's not a leading 0 if it's just 0. So therefore, you do an if statement of, okay, if there's at least 1 0, meaning that there's at least one sequence that's, with 0, then you add 1 because this is a 0 sequence. And that's basically it. I feel so bad not getting this because I feel like this is essentially digit dynamic programming. You may hear it that way, 1 digit at a time. But for some reason, I really just didn't think of the uniqueness really threw me off. I guess this is something that I learned today, so that's good. But yeah, and then going backwards allow you to answer this question of, okay, if it starts at 0, what would it be, right? Because now we're adding them from left to right. Because if you're going the other way, you're gonna have to do a lot more. So yeah, that's all I have for this explanation. This explanation, this is linear time because you just do a for loop. This is almost embarrassingly short and easy. Now that you know the answer, right? Like for me, I'm embarrassed. You could do your own embarrassment at home. It's up to you. But I feel embarrassed that I didn't get this. But yeah. Anyway, you could go back to my other explanation, the more complicated, unproud explanation next. Well, within reason. Anyway, so yeah. So this one. First look to see that n is 10 to the 5th, you're probably guessing dynamic programming, and if you guess that, you're right, especially if you solve Q3, because that was also dynamic programming somehow. So I don't, so the one thing that I did do, and you can watch me solve this live next, is that I actually wrote a brute force algorithm to kind of test my solution. That's how I kind of, that's how I kind of figured it out, or like it made me figure it out without having like 10 wrong answers. But the first idea that I would say is that the way that so there are a couple of observations, but the first observation that you should make, or that I made anyway, is that my computer is slow. So that is the first observation that you should make. But the second observation after that is that only the zeros between the ones. Oh, okay, no. I mean, that's an observation you make, but for me, the observation was that going backwards is a little easier than going forwards, meaning going from right to left instead of left to right, because because then I don't have to care about leading zeros as much, and then it becomes more straightforward in that way. So here I'm going to explain kind of my thought process, because, and to be honest, I don't have a great explanation about it, but the idea is that, okay, and this is how dynamic programming problems are done anyway, I suppose, but for every, now that we're going from right to left, right, so we're going this way, and as soon as my computer lets me, I will continue to go that way, right? So we're going this way. Let's say we start at 1, and this is actually code that I submitted because I was testing it manually. Like, I was trying to go through a test case that I know I have a wrong answer for from doing the brute force. You could see me do this live, so try to figure that out. So, okay, let's start with 1. Well, 1 only has 1, so yeah. And I actually tried other cases first as well. But yeah, so now let's say you have 1, 1, which is the suffix of 2 numbers. What does that mean? Well, now you have 2 possible numbers, right? Basically, you have this 1, which we can either not care about, and if we don't care about, then that's fine. But if we don't care about it, then your answer is just exactly the previous one. So that doesn't, like, it doesn't change the result. But if we do care about this 1, then you basically take the previous 1 and then you add a 1 to it. So then now your possible results of 1 and 1, 1. Because, well, 1 is just if you ignore it. So, and if you ignore it, you just basically, you know, take the copy and paste this answer. And if you add 1 to the prefix, you have this. And you may wonder how I came up with these rules. And I did kind of have this consistency. And you can watch me solve it live during the contest. And that was my idea. And I honestly, if you saw me, I went through a lot of small example cases to kind of get intuition, to learn, to feel it out, right? Okay, so the next one is 1, 1, 1, and this actually now becomes a little bit trickier, because there are a lot of ways to go wrong about it and still get the right answer, and that basically was how I got it a little bit. So basically, you have 2 choices, right? You could either not use this 1, so that's basically just copy and paste from here. So let's just say this is 1 and 1, 1, and you can use this 1. So that means that you take every number in here and then you add a prefix of 1. So you have, and that includes the empty string, to be clear. So in that case, you have 1 because you added to the empty string. You have 1, 1 because you added to the 1, 1. And then this, right? So basically, you take every string that's here and then you add it to 1. Okay, that makes sense so far. Oh, except for that they're dupes, right? So how do we get rid of dupes? Well, we get rid of dupes by subtracting, it turns out. So this would, it turns out that you get rid of dupes by taking by subtracting this number. Why? Because this number, so the idea here, okay, I got it. Sorry, I have to try to figure, I'm doing this live, so I'm trying to think about how to explain it in a good way, right? So basically, the duplicates are the same as if you add this number but not this number. That's how you get the duplicate, because your previous duplicates is the same as if you did not take the previous one, right? Because if you take here and you add a 1, that would give you the same, or if you add, okay, let me phrase this another way. Sorry, friends. But if you add, let's say you have this prefix, right? Let's say we ignore this for now. If we add this 1 to this 1, this is the same as adding this 1 to this 1, right? So these two have the same sequence. So that means that in order to figure out the duplicates, the number of duplicates is if we add 1 to the previous one that already exists. So that means that we have to subtract it from this one, because this one is the same as this one, right? Times your current one. So that's basically the idea. Yeah. So just to reiterate a little bit, sorry, I know that what I said probably didn't make that much sense, but this is basically if we did not add a 1. This is if we add a 1 to every previous, basically this one, right? We add a 1 to every previous sequence here, minus the dupes, right? And why are these dupes, or how are these dupes? These are dupes, minus dupes, and dupes are basically if we did not take the previous one, right? So that's basically the idea. This maybe is a little bit tricky to say, but yeah, but that's basically the idea. And here, then now you would get 3, right? So you have 1, 2, 2, 2, 2, 2, 2. Anyway, and then now this one has, so if you have a 0, it doesn't change anything because it's a leading 0. So that's why you just skip it, right? But now you have 10, or you have two digits. What does that mean? Well, that means that now, looking at everything here, well, this is just if we don't add a 1, right? So here, if we did not use this 1, and then here you add. So what do we add? So now there are 2 scenarios, right? One is if we take every number here and we add a 1 to the beginning. So 1, oops, 1, 1. And then here, but also now you have 1, 0, right? Having 1, 0 means you can also add 1, 0 to the beginning of all these. So yeah. Use a 1, use a 1, 0, right? And of course, just skipping ahead a little bit, if this has 5 zeros, then you have this times 5, right? Or times 6, or whatever, depending on how many zeros you have. So yeah, so this reduces a little bit, but then now you have to get rid of dupes, and of course, dupes is if we add just 1 to all these things. So yeah, so this is basically we ignore this one. Maybe I'll write it here. So we can only get dupes if we have here if we add 1 to all the previous sequence of this thing, because this is the only way to get dupes, because this is decoded to this, which means it has all the previous unique sequences, and it has all the unique sequences, so that means that this is repeating, so we want to subtract that, right? And I'm just going to dot this. So that's basically the idea. I know that this is a very tricky understanding. Try working out more problems and try to figure that out. I think that's how I would talk about it. But hopefully this is an idea to at least allow you to get kick-started or start kicked it. So yeah, this is my implementation. Again, I even implemented this, and this is a strategy that I recommend, just brute forcing it just to kind of get an idea. And here, it's just an implementation of what I said, right? So this is basically the last total, and this is the minus total, yeah, total 2 indexes ahead, and this is just the current plus 1. This current is the number of zeros, and I added plus 1. So this is basically the answer. I mean, I have some extra stuff here, but that doesn't do anything. I just look at the last element. So yeah, so you can look at it here. Let me actually put this on one screen so you could see it on one screen. And I had a lot of debugging things because I was just, I don't know. But yeah. So this is going to be, and I do this in reverse order, as you can see. This is going to be linear time, linear space, as you see. But if you if you have a eagle eye, you can actually reduce this to all of one space by noticing that at most we always look at just the last two total. And yeah, so this is always gonna, you can do this in all one if you like. So yes, I recommend you practice that even if you get it. Let me know what you think, and there's some mod math, but yeah, this is a very hard problem for me because yeah, I mean, you can see that I didn't even explain it that well, to be frank. So yeah, so let me know what you think. Let me know if you have a better explanation. Let me know if you have a better visualization. Yeah, that's all I have. You could watch me sub live in the contest next. I tried a lot of things during the contest, so it's a long video. Skip ahead as you need. But yeah, I'll see you later. Bye bye. But okay. How many people have solved this yet? Number of unique good subsequence. And no leading zeros. Mod. Length is 10 to the 5th. I think about this one. Did anyone solve this yet? Ten to the 5th. So I'm gonna guess it's some sort of dynamic programming. So what's the recurrence? If it is a 0, if it's a 0, then it is the number of ones before. Is that true? No, because then it's unique, right? The unique part is makes it a little bit trickier as well. So okay, let's say you have 0. I mean, we could special case out a 0 if there's a 0. If there's a 1, so then what happens after that? If it's all ones, then it's just ones. So then for every 0, we do something funky, maybe. For every 0, we could look at the zeros as the delimiters, maybe. Did anyone solve it yet? Oh, I guess they don't show up the first 10 minutes or something. If we look at the zeros as delimiters, what does that mean? So there's 1 and this, so that's 2. 0 is delimiters. Does that make sense? If that's the case, then it's just... No, that's still n squared though, if you don't do it smartly. Wow, people are really fast. Oh, already got it, so I don't know. Or 2 people got it, so I'm just... It's going to be dynamic programming, but just seeing how many people got it. Wow, 11 people got it already. People are very good at dynamic programming. We go backwards. Can that work? Because then now it's... Now we don't care. Okay, maybe that's why. I just have to go backwards, because then now we don't care about deleting zeros. It's just that now we can remove if the last element is 0. Okay, so the base case is 1. Start. So we add a... So basically it is, if the ones are the delimiters, then the number of different ones are just something about the number of zeros. Okay, and we can solve that just looking backwards. Okay, let's see. I guess could be n. I don't even know. Is this right? Okay, so let's say we have something like this. Then in this case, okay, so let's look backwards. 1, the answer would just be 1, 0, 1. The answer is 0 and 1, so it's 2. 101, this is one of the inputs, so that's 5. Or 101, this is at least 5. Does that change? I guess it doesn't change the answer. If this is the, yeah, okay. And then now, still 5. Okay, now which one is this one? Well, this one we have all these strings. So these are at least, these are the answers, and then there's also just 101. This one. Well, this. How do you do it? Because we can't add. Oh no, there's no 01, so I can't do 101 again. Can I repeat? Can I just do that? Well, I can add this one, right? Because if I just add 1 to 0 and 1, that doesn't work. So basically we can, because this one would already add it, so we only basically care about things that this one is directly responsible for, which is, I guess, this one, and this one. So this is actually 3 for here. So this is 5 in total, but 3 in whatever. And this is 0, but I mean, I think we just ignore these. And then here, then it looks at this 3. Right, so so the last number that is 3, so it only cares about these 3, right? And then these 3, we can add a 1 to a prefix of all of them, and that'll be unique by definition. And then we can also add a 1, 0. I think I must, wait, did I? No, these are unique, right? I think I just cannot. Okay, I'm missing a 1 here. Okay, so that means that for 3 zeros we can choose 0, 1, 2, or 3 zeros on top of the previous one. Okay. Okay, let's actually, maybe that's not the thing I want to do then. Okay, I think I have an idea now. I should have thought about it like this a little bit earlier. Instead I wasted a lot of time, and I think a lot of people got it already, but that's okay. So the n is not necessarily binary, but how do I want to do this? Let's see. So basically now we have all these zeros between the ones. So okay, zeros is equal to I guess this is 0. And then for x in binary, let's just say we look at it backwards. When we look at it backwards, we have, let's just say, current 0. If x is equal to 0, then we increment. I guess I already wrote this, but otherwise current is equal to 0 because we update. But then now zeros dot append current. So then now we should have something like 0. Ooh, that's not good. Oh, whoops. That's fair. So now we should have something like 0, 1, 3, dot, 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 right? Okay. Oh yeah, I have an extra 0, but that should be okay. So 0, 1, 3, 0, 0, 1. Okay, so I think I'm okay here. And if there's any prefix of 0, it doesn't really matter. And we have to add in 1 at the end, so make sure I remember. Okay. So then now we do the math. Okay. How do I want to do this? So this is the number. I can actually probably even do this here. So I don't even need to append this then. Yeah. Let's just do anyway though, because let's not try to be clever. Okay, so now we know what the previous thing is. So the current is going to be the number of zeros, and then the previous result is the prefix. So the prefix of -1 is number times current. Is that right? Times 2 maybe to add? No. You want to add, because if you don't add, then you don't have a new prefix, or you don't have a new amount anyway. Okay. And then now just returns sum of prefix. This is actually 1, I think. So then this should handle all the cases, maybe. I need to do mod in more places. Okay, well, that's not a useful response, but I just want to see if this works. 111, that's definitely not right. Okay, Oh, because this gets 0. So what happens if they're next to each other? Then this is just... Oh, this is current plus 1, okay. Two, three, four, okay, that's not right. Okay, whoops. Let's print it out. Okay. So this should be 2. Why is it giving me 3? Oh, because I add 1. Because it's 0, 0, 0, so then it's... Oh, because I assume that 0 is part of it. You know, that's not true. How do I handle the empty 0 case? 4 is not right either. Why is 4 not right? Because... So after this is 1, that's fine. After this one, this should be 3, because this appends 1, 0. I think I'm not handling the 0 case correctly very well, but I think I have the right idea, or at least right path. So okay, how do I want to go about this then? How do I... This actually has a very good... Both of these things have a good case, so... Okay. We can maybe shortcut the first one just by if 0 not in binary, then just return the length of binary. I think that's fine. Though I don't know if that's going to come back to bite me later. But here, we... Basically... Now that 0 does exist, what does that mean? I think I have to parse out the first 0 in a better place. I think I'm handling the empty case and the 0 case incorrectly. Or not the same anyway. So this should be 0. This is the last amount. No, this is 1. What happens if I see a 1? So if I just have 1, then this number will be 0, and then the current will also be 0, but that part's okay. Is it this plus 1? Does that even make sense? No, I don't think so. Well, it's just empty string. I'm not handling the empty string correctly, that's why. Is this correct? Now I don't know. Because it could be that this is correct and I just have to add 1 for the 0 case. Maybe I just don't handle the 0 case. I don't know what the answer is for this one though. And I don't know if there's any way to tell. Maybe that's right, I don't know. But let's see. Okay. I don't know if I'm wasting too much time doing this, but it'll be okay. Well, that's not even close to being good, but that's because this is just really wrong. Oh no, that's not right, but it's if can't even write the brute force correctly. Oh yeah, because now I don't have those zeros again, so okay. But now let's try some big... Oh. Alright, let's see if these match. I'm probably just gonna submit it. Okay, they do not match though, so I'm not gonna submit it. That's sad. Save myself 5 minutes, so I end up taking like 2-3 minutes doing it, so I don't know if that was a good 5 minutes thing, but that's okay. Okay, so let's look at this one. I think there's only 14. Okay. So then zeros is 2001. That makes sense. 2001. Okay. And then now you start with 1 because that's not true. This should be 3. Maybe I'm just doing it wrong. Well, I mean, I'm definitely doing it wrong, but I should definitely be 3. Maybe I need to handle the first one in a weird way. Maybe this is just weird because this is the last number. So the empty string. Is empty string a good string? Let's just say empty string is a good string again. And then I just subtract it later. So this is 3, which is true. This is 3, which is true. Wait, is it? Yeah, okay. This is 3, that's true. And then this is 6. Is that true? Okay, let's do a dumber example first. Like this one. Why do I return 2? No, I return 3 because I have this +1. But the answer is 2. Because this should give me a 1, which is true. But the empty string, we don't care about empty strings, right, Larry? Yep, no we don't. So then we remove the empty string. This may be one of those problems that I end up spending too long on. Okay, so this is good now. This one we skipped because we cheated. Okay, this one, why is it 4? Because okay, so we have 2 levels of freedom here. It should be, so this is 1, and then we have 2 levels of freedom. How does that work? This is where I need paper, but I'm doing it for y'all instead. Okay, so let's say 1. This is just 1. Okay, and then 0, 1 we ignore, and then 1, 0, 1. This one we try to add 1 to this, and then we try to add 1, 0, 1 to this. So that's why we have 2. Okay, but we don't do, what we don't do is we don't have but here we don't have, what we do want is this 10. Okay, I see. So it's something about the max, maybe. Well, I guess it's the total number of ones, or the total number of zeros, because that's the number of zeros that we can have with this as the 1 and all. Okay, so then that means that, okay, so this is good, I think, but it also means that here there's 1 total 0, which means that we can have these 2. Okay, let's see if I can play around that idea. This is 1. Nope. What am I doing? And then this plus, because the number of zeros is just the answer. Maybe. Maybe plus 1 more. Nope, not good enough. Got this one right though, but okay. So why is it off by so much? What is this one? This one, my answer is 10. The right answer is 17. How do you have 17 on this? Okay, I guess there is 17 on this. But, well, these should not be ones. Well, this should be 1, but now we add. I think my adding is a little weird. I think that's why. Because now we want to add 1 to all these is fine, but 1 0 we also want to add to 1 1 2 1 3 1 4 and 4 ones, right? Because you have all these prefix. So okay, let's try a easier incorrect one now that I think I see it. So you have this one, which I put 7 because this last one just times 2 of the previous, but that's not true. What it can do is have 1 2 3 4 things that it wasn't. Does that only apply for the first? And I'm really behind now, I think. A lot of people got it. Wow, a lot of people are smart. I was so fast on the other ones, but I just can't get this one. The recurrence is hard for me. Because here then. Okay, let's. You don't need all these things. What does this look like then? Yeah, I'm off by a lot. Because now I can have 1 0 0 and then the ones before that. A lot of people got this. Pretty impressed. I don't know if I can. This is not my type of problem. Maybe. So I have to figure this out. I have 45 minutes though, so that's a long time. So this 2 is not just applied on this element, it's this OR element. Just I thought that that would add uniqueness. That's why, because just playing around. Let's see. This would be too slow anyway, but I just want to see if that works. Nope, that's clearly overcompensated. Because, well, maybe now it doesn't need to. No, it still need to press 1. Because it also adds the empty string, I guess, maybe. Now I'm just like hacking it, so I don't know. Well, mistakes were made, I suppose. Okay. I feel like I have the right idea, but I did for a long time, and now I'm just like way behind. All because of this particular one. Because that's the question. Okay, so 1, this is just 1, 1, 1, 1, 1 is the new one, new number, but then now, how do we handle the 1, 1, 1? Because now, this is the funky stuff, is that you can add 1 to only this one. But then you can add 1, 0 to all of these. So 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, right? So there's something about the total, and then just adding a 1. And then now how do you do this, for example? Well, so you add 1 to every number here, which is this thing, plus 1101, 11011, 110111, plus, then you add 1, 0, and you only add 1, 0, no, you add 1, 0, and 1, all of these, right? So 1, 0, 1, 1, 1, 1. Did I have a case? I think I have this case. What was the answer? 23. I don't think I have close to 23, so I'm probably missing a lot. But well, yeah, because I have 1, 0, 0, 1, 1, 1, for example. How did I get that? Oh, it's just this. But I don't think that's still enough. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19 with the 0. So I'm still missing 4 numbers, but well, for example, I'm missing 100. And just basic things like 1, 0, 1, 10, which is not even limited anymore. This one I guess is used. I don't know. I don't know how to do this. Well, and there's duplicates, otherwise, okay. Maybe I just don't know. It's tragic. Oh, am I thinking too weird? So 1 0. So you have all these unique sequences. So we can definitely add 2 of them here. Well, this one, I guess. Yeah. Because then you have 2 times all this stuff. But this is way more than 2 times that stuff, right? I have to think about a different way of doing it, because how do you get 1001 in this case? I guess how do you get all this stuff in this case? And why is it that you don't use it here? So this one you built on. This will always give you a unique one, obviously. But then how do you get this one? Well, this one is just this. Somehow keep track of the maximum number of zeros, or something like that. Because now you have 0, so then now, what does that mean? And if now here you have 2 zeros, what does that mean? That means that everything before that is. I've not made any progress. can take the sum of all these. What happens if we do we know that these three are duped. Can we subtract them? Is that how? And apparently this is a not that hard problem, but I'm having a lot of trouble with this one because 200 people solved this. I don't even have a clue. Yeah, maybe I don't know how to do this one. I'm just missing an insight that I can't figure out. How do you do this math of uniqueness? Tell me how do you do this math? This is 7, right? This. Nope, there's 9 because it's this plus a 0. What am I missing? Oh, whoops, 10. And then just 0. Okay. So, okay, so let's just say that this is the case, right? We can't sum it because now we know that there's 3 dupes. How do we get the 3 dupes there? Right here. How do we get the 3 dupes out of here? Get these dupes out of here. Oops. What does this mean? So is this plus, but then like now this is too big, right? What do I get again? 25 because I don't dedupe. Because this is 4 and then now I have 2 degrees of freedom. Wait, what? Oh, well, yeah, 2. So 2 times the sum of all this stuff is 16. Though this should be a 3. Oh, there should be a 1 even. Still not quite right, but just kind of, you know, not unexpected. I don't know what I'm doing. I'm just trying different things. I don't know. I don't even know how this formula works. I was just doing, I don't know. This just feels like whatever, but this is just weird. Oops. Because I already have total. I don't use total at all anymore. I don't even know how this works, to be frank. I mean, if this works, okay, well, maybe not like this. Okay. if okay, let's try at least a few more things before I try to optimize this to be right. How does this formula even work? I don't even know. Sometimes you just get lucky, I guess. But I guess I recognize this pattern of some sort. But okay, but now I have to think about how to do the prefix sum essentially. So sum of the prefix is the sum of the first thing. Whatever. Oh man. I have 20 minutes to figure out this formula, so I think I'm good. Okay, so this does match. Okay, so that means that we should be able to go do. Okay, this is still matching. Okay, and then that means that this is total minus 2. Maybe give me an out bounce though. Yeah, okay. I don't know. Okay. And this is actually just okay. Now we can do some math with respect to mods. Let's just make this. This is just for timing anyway, but should be okay otherwise. Still don't believe this though, to be honest. I still have 19 minutes. So let's... I mean, I am not fast enough anyway, so let's at least kind of look at... Okay. Huh. Okay, if this is good, I'm gonna submit, I guess. Yeah, I guess so. Okay. I think that. Let's give it a submit. Been testing too. Okay, I don't even understand how this works, to be honest. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great week. Have a great, contest. And yeah, stay good, stay cool, stay healthy, and a good mental health. I'll see you later. Bye-bye.